Hello, welcome back. The title of this lesson is called The Law of Sines. This is part 1. So in the last few lessons, we learned about the law of cosines, and that applied to any triangle, and it was basically a modified form of the Pythagorean theorem with an extra term on the end that basically corrects if it's not a right triangle. We can use it for any triangle at all. It's very useful for lots of different cases. Now here we have the law of sines, which is kind of the sister a formula or equation or theorem, and it's also applicable to any triangle at all. It does not have to be a right triangle. Actually, the law of sines, in my opinion, is a little bit easier to use than the law of cosine. So let's just write it down and talk about it. So this is going to be what we call the law of sines. And again, you use it for any triangle. It does not have to be a right triangle. Well, first, let's draw a triangle. Now, I'm going to draw a triangle here, but just keep in mind it can be any shaped triangle, right? So let's say I have a triangle that goes, up like this, and then, down like this. This is not an equilateral triangle. You can see that these sides, they look kind of similar, but they're not the same length, right? So here we have, we can label these guys. This can be angle A, and this can be angle B, and this over here can be angle C. And opposite those angles, here we have side A, lowercase a, side B, lowercase b, and side C, lowercase c. Again, this is not an equilateral triangle. This is any size triangle. Now I'm going to write down the law of sines, and what we're going to do is we're going to use it to solve a couple of problems, and we're also going to derive it at the end of the lesson. So stick around with me at the end of the lesson so you'll understand how to use it, but also where it comes from and how it's derived. Because when possible, I want you to know where things come from, so you don't think that everything is black magic, that we know we can figure out where things come from and they don't just fall out of the sky. We're going to do that at the end of the lesson. You're going to find it's not too hard to understand at all. So the law of sines says that the sine of angle A, in this case this angle, divided by the side opposite, which is the length side A there, is equal to sine, if I can write the word sine correctly, the sine of angle B divided by side B, and that's also equal to the sine of side C divided by, or angle C divided by side C there. So here is the law of sine. So sine A over A equals sine B over B equals sine C over C. All right, so now you know why in triangles we label angle A, B, and C with capitals, and then we label the opposite sides, lowercase a, lowercase b, lowercase c, because if you don't have A, B, and C, if you put, theta 1, theta 2, theta 3, or if you have theta for this angle and alpha for this angle and phi, which is another Greek letter for this one, then it gets hard and it looks difficult. But if you label it capital A, capital B, capital C for the angles, and lowercase a, lowercase b, lowercase c for the corresponding sides opposite those angles, then the law of sines is very easy to remember. It's much easier to remember than the law of cosines. All right? So what this is basically saying is that there's some aspect to angle A that when you put it in the ratio, when you take the sine of it, the ratio of this related to the length of side A is exactly the same ratio as if we take the sine of this angle and compare it in a ratio format with the opposite side. But that ratio is also the same as the ratio of the sine of the third angle C in ratio with the length of the side opposite. So it's a relationship between the ratios. It's not the angle itself divided by A and the angle itself divided by B and the angle itself divided by C. It's the sine of those angles. And if you remember back though, I'm not going to draw it, but if you remember back the right triangle, right? The sine of an angle here is the opposite side. It's the vertical projection, the vertical height. If you think of a right triangle, the sine of the angle is giving you the vertical projection. So if the angle's bigger, then the sine is going to be bigger, right? If the angle gets to 90 degrees, then the sine is equal to 1. So as the angle gets larger, the sine gets bigger. And if you think about it, in a triangle, if the angle gets bigger, in the corner of a triangle, if the angle gets bigger, then the side opposite that angle must be bigger also. I'm going to say that one more time because it's important. I'll turn sideways. If the angle gets bigger, then the opposite side that connects the ends of those rays that make the angle has to also be bigger. And since the sine of an angle gets larger when the angle gets bigger because it's the vertical projection, then it kind of makes sense that the sine of an angle would be related to its opposite, the length of the opposite side, right? And it turns out that the ratio of each of the sides of the angle to their opposite side, they're all the same in any triangle that forms a closed three-sided shape. Now we're going to derive this, but for now, let's just use it because we can learn a lot about what happens when we just use it as well. So let's say for problem number 1, I tell you that one side of the triangle is 14, meters long, let's say. I tell you that angle A is equal to 25 degrees, let's say. I tell you that angle B is equal to, let's say, 75 degrees. And I ask you, what is the length of side B? All right, so the first thing you should do, just as we did in the last lesson, is draw a picture. Even if your picture isn't like to scale or even very accurate, draw the picture. It's going to help you, right? It's going to make it very, very simple. So what I'm going to do is I'm going to draw a picture that's going to look very much like the one above. I'm just literally going to draw a triangle. I don't care what it looks like because it doesn't matter. I'm going to put that this is angle A, and this here is angle B, and this is angle C. And I'm told in the problem statement that angle A is 25 degrees. So I'm going to put this here and remind myself this is 25 degrees. I know that, so I'm going to put it into the diagram, right? And I'm also told that angle B is 75 degrees. So I'm going to put angle B is 75 degrees, and that's this angle right there. So that's given to me. And then I'm also told that side A is 14 units long, whatever, millimeters, centimeters, whatever. And side A is opposite of angle A. So this has to be side A, and that's a length of 14 long. So now that I have it in picture form, I can write the law of sines. Now, the law of sines is written as three things that are all equal to each other. But really, you're just trying to find, in this case, an unknown side, side B. So you don't need to write all of the equalities out. You don't need to do that. You just need to write what is needed for you to solve the thing. So let's just go like this. We know that from the law of sines, the sine of angle A divided by the length of side A is equal to the sine of angle B divided by the length of side B. That's right here. We also know that this is equal to side C, but we don't need to write anything down. We don't need to put the equal sign with side C because we're not asked to calculate anything related to side C at all. You could write it down, but you just don't need to because you're not asked to find anything. I'm just asking you what is the length of B, side B. So let's plug in what we know. Sine of angle A is 25 degrees, so I'm going to put the sine of 25 degrees divided by A, which is opposite of that. It's 14, meters long or whatever. And then we're saying that this is equal to the sine of B, but I know that the sine of angle B is 75 degrees and divided by the length of side B. So B, this is the unknown. This is what I'm trying to find right here. And so now I have an equation I can solve. Notice that this is a number, this is a number, this is a number, this is an unknown. So yes, it is true that this is also equal to the sine of C, angle C, divided by side C. It's true, but you don't need to write that because I already have enough information written down to solve for what the problem has asked me to solve for. So now that we have written down enough to solve the problem we're after, we can go ahead and calculate the answer to this problem. So when you take 25 degrees and take the sine of it in a calculator, you get 0.423. You still got to divide by that 14. On the right-hand side, when you take 75 and take the sine of that in a calculator, you get 0.966. You still have to divide by B right here. Now, when you take 0.423 and you divide by 14, you get 0.0302. And then you have to keep what's on the right-hand side, 0.966, and then you're going to divide by B. All right? Now, to figure out the answer to B, we're going to multiply both sides of this equation by B. On the right-hand side, B on the top and B on the bottom will cancel. On the left-hand side, you'll still have 0.0302 times B. And then on the right, all you have is 0.966 left over. All right? So then, to finish it all up, B is going to be equal to this number divided by this one. So 0.966, and we're going to divide that by what's on the bottom here, 0.0302. 0302. So 0.966 divided by 0.0302 works out to 31.99, and that's so close that basically we're just going to say it's equal to 32. And this is the answer we're going to put down here, 32. So this is the law of sines, ladies and gentlemen, and it's not that difficult. I mean, really, when you think of the law of cosines, you have, a squared is b squared plus c squared minus 2 times a times c, and it's just a bunch of stuff with a cosine at the end. This is just a ratio and proportion kind of situation. And this is a good example of why we spent so much time learning how to solve equations in the past and learning how to solve ratios and proportions. To get b by itself, we multiply both sides by b, it cancels, and it shows up over here. Then we divide by this, and we get a value of b is equal to 32. So the length of this side of the triangle, given all the information here, has to be 32. All right, now what we're going to do is we're going to solve one more problem to give you a feel for how to use the law of sines, and then we're going to derive so you can see where it comes from. All right, next problem. So here we have, if I tell you that b is equal to 3.40, let me make this decimal a little easier to read, 3.40, and I tell you that angle A is equal to 110 degrees, and I tell you that angle C is 50 degrees, tell me what the side A of this triangle is. So again, we're going to draw a picture, but it doesn't matter if it's accurate. Don't stress out about the angles and making it look perfect. It doesn't matter. Just draw a triangle. It does not have to be an equilateral triangle or anything. I'm just drawing something here. This is angle A. This is angle B. This is angle C. And opposite of this, you have side B and side C and side A. And so now we're going to put down what we know. From our problem, we're told that side B is 3.4. So 3.40. We're told that angle A is 110. So I'm going to go down here. I'll put a little angle marking here. 110 degrees. That's what this angle is. Angle C, this one, 50 degrees. So I'm going to put that here. And that angle is this one. And that's it. Now I'm trying to figure out what this one is. So I'll put a little question mark there by side A. So if I write down the law of sines, let's see what we get. Let's just write it down straight away here. It's the sine of angle A over length A is equal to the sine of angle B over the length side B is equal to the sine of angle C divided by the side of the triangle labeled C. And we try to put in into here and see if we can solve it. So we know angle A is 110, so this is a number, but we're trying to find A, so this is unknown. But we have this. Sine B, we don't know what B is, right? But we do know what this is. So this is known and this is known, but these two are basically unknown. So we can't just write that down and solve for anything because we have two unknowns. And then we have sine of C, but we don't have this side. So we have only one thing known in this fraction. It's this one. And over in this fraction, we have only one thing known. That's this one. So we can't solve anything. And over here, we only have one thing known. That's this one. So you feel like you're stuck because when you write down the law of sines, no matter what you put, the information that you have in there, you cannot just write one equality and solve it because you always have two unknowns everywhere. So what do? Then you remember, wait a minute. I know this angle. I know this angle. Every triangle has 180 degrees. So the secret to this is you have to find the missing angle first. And you can do that before using the law of sines because you know that all triangles have 180 degrees. So angle B is the missing angle here. So you can say angle B is equal to 180 degrees minus this angle, 110, and also minus this angle, 50 degrees. All right, and then angle B, when you do this, you're going to find that it's equal, if I can write B correctly, is going to be equal to 20 degrees. And now that we know that, we can say that angle B is equal to 20 degrees. And now we have enough information to solve it. Now we have two pieces of information. We have this, and we also have this. And so we'll be able to figure out what side A is. Now we were given angle C. We don't use it in the law of sines, but we did have to use it to find angle B. We used it in step number 1. So let's go ahead and plug in what we now know. So the sine of A is the sine of angle A, which is 110 degrees, and divided by the length of side A. That's what we're trying to find. Then we say that that's equal to the sine of B, which we did not know originally, but now we know it's exactly 20 degrees. And we divide that by B, which is 3.4. Now we can stop. We can solve this for A because we have number, number, number. We don't need to write another equality over here because we don't need it to solve what we're trying to find. We did need angle C to make progress, but we don't need to write it here to continue the problem. So let's see what we have. Now, in order to solve for a, we could calculate the values of all these, and that's fine, but let's just do a little manipulation first, just to get a little practice. We're going to solve for a, so let's multiply a on both sides. So on the left, when you multiply by a over here, it cancels, so it disappears. On the right, it's going to be the sine of 20 degrees divided by 3.40 multiplied by a. So make sure you understand, multiply left and right-hand side by a. On the left-hand side, it cancels. On the right-hand side, it's just multiplied by a. Now, we want to solve for a. So we need to divide by this entire ugly fraction here. So what we're going to say is that when we do that, it's going to be the left-hand side, sine of 110 degrees, put a long fraction bar, and we're going to divide by this whole thing to get a by itself. And that is the sine of 20 degrees divided by this, 3.40. Make sure you understand, to get a by itself, we take this and we just divide by this fraction, bring it up and divide. But now we have this thing divided by a fraction. So to actually calculate it, the numerator, you can write as sine of 110 degrees over 1, because every numerator you have is this thing divided by 1. Change the fraction division to multiplication, take the second fraction and flip it and multiply 3.40 divided by the sine of 20 degrees. All right, now we can do something, because we can say that a is equal to, what is the sine of 110 degrees? Put 110 degrees in your calculator, take the sine of it, and you're going to get 0.9397. That's what we have here. And then we're going to multiply this by 3.40. And when we take 20 and take the sine of it in the calculator, we get 0.3420. Like this. All right? And then finally, when you take this number, multiply by 3.40, and then divide by this number, you get a value of a is 9.34. And that's the value of the answer. 9.34. So if the lengths of the triangles were in meters, then it would be 9.34 meters, for instance. So when you're using the law of sines, it's a good idea to draw a picture, first of all, then write the equation down, put in the numbers to see what you have. If you have enough, like in the first problem, we just put it in there and we immediately could solve it. And so we solve it. In the second problem, when we put everything in, we couldn't solve it. So then you have to go back and find something else. And we went back and found out the value of the remaining angle in the triangle first. Then we use the law of cosine, or the law of sines, to figure it out. Now what we're going to do is show you where this comes from. So is it the kind of thing that you would figure out on your own? Probably not. Is it the kind of thing that we're born with, the knowledge that you just wake up one day and say, I know how to write the law of sines? No, it's not. But it's the kind of thing that once you see it written down, you can understand it. And you can say, I get it. This makes sense logically. And so based on starting from here, we can end up at the law of sines. And then from henceforth, I can trust that the law of sines is true. So it's not something I think you're going to have to write down on a test necessarily, but it does help flex your math skills and also give you confidence to know that the things that we study come from someplace logically. So let's go to the next board and start this process. So we're going to proof of law of sines. All right, so what we want to do, first of all, is we want to draw a triangle. Makes sense, right? So let's draw a triangle, and let's superimpose it on an XY plane. And that's just going to help us visualize what to do. It's not totally required, actually, but it helps us visualize what to do. So let's draw a triangle that goes something like this, right? And, of course, this bottom part is the other part of the triangle. All right, now I'm going to call this corner, put a little dot there if you want. I'm going to call it angle A. I'm going to call this one angle B, and I'm going to call this corner over here, I'm going to call it angle C. All right, now what we're going to do is we're going to calculate the area of this triangle. And we're actually going to do it 3 different ways. We're going to find the area 1/2 times base times the height. That's the area of any triangle. We're going to apply it to this, and we're going to do it 3 different ways. And because the area of a triangle is always the same, all 3 ways that we calculate it is all going to be equal because they're all the same area, because the area is always the same, right? And notice the law of sines has 3 things equal. So the 3 ways we calculate the area, we set them equal, it's going to end up becoming the law of sines, right? That's the punchline. So all we have to do is figure out the area of this triangle. So how do we find the area of a triangle? Well, you need 1/2 base times height. So let's write down the different sides here, okay? So this side from here all the way to here is opposite of capital B, it's lowercase b. Opposite C is lowercase c, opposite A is lowercase a. Same thing as always, right? Then we come in here and say, we need 1/2 base times height. Well, what is the height of this triangle? Well, what we do is we come over here and we say that this is the height h, right? So what we want to do is calculate the area 1/2 base times height. But in order to find the height, see, that's a new variable. So we don't really want to introduce a new variable. What is the height actually equal to in terms of what we know, right? The height, you can think of it, if you kind of like cover this up, just focus on the left-hand side of what's going on here. There's a right triangle here. This is a right triangle. So we can use our knowledge of sine and cosine. How can we write h? H, we can say, is the hypotenuse C times the sine of this angle down here, which we know is A, times the sine of A. Let me just stop. You have to understand this, or nothing else is going to make sense. And this is just straight up telling you the sine of an angle, this angle, is equal to the opposite side, over the hypotenuse, which is the hypotenuse here. So again, cover this up, pretend it doesn't exist. The sine of this angle is the opposite side divided by the hypotenuse. Sine is opposite divided by hypotenuse. I'm just rewriting it and saying that h is c times sine angle. So you can think of it as the hypotenuse, the sine projects it vertically, you get the vertical projection, we call it h. That is a new variable h, but we're putting it in terms of what we have written on the board here, c times the sine of the angle A. All right, so then what is the area of this triangle? It's just 1/2 times the base of the triangle times the height, right? So let's go ahead and write that down. Area of this triangle is equal to 1/2 times the base, but the base is just b, that's just length b of the triangle, times the height. But the height is this stuff. So we're going to put c times the sine of A. So boom, there's the area of the triangle. 1/2 BC times the sine of this angle. If I told you the length of B, and I told you the length of C, and I told you the angle A, you could just put it in here and you would find the area of the triangle. And it would come exactly from 1/2 times base times height, which is what you learned back in 4th or 5th or 6th grade, right? Now that's that's way number 1 of calculating the area of the triangle. Now let's go calculate the area of a triangle in a slightly different way, and let's set it equal to what we just got here, because the areas have to be equal, right? And we're going to find out that this yields the law of sines. Notice that the area of this triangle has a sine in it. And notice the law of sines has all these sines in it. So the law of sines, this sine that's right here, it's going to feed into to where we're going, right? So I don't want to like make it a big mystery. That's what's going to happen. So this is number 1. Number 1 area calculation. All right, now let's do number 2 area calculation. Number 2 area calculation. We're going to do it right down here. All right, so what is another way of writing this height? We did it before as c times the sine of this angle, right? That's the height. But we can also say that the height, right, is, if we cover up this triangle, we can say that the height is this hypotenuse times the sine of this angle. So let me write that down. It's the hypotenuse on this side times the sine of C. How do I know that? Because if I cover it up, I have a right triangle here, and the sine of any angle is its opposite side divided by its hypotenuse. And sine of C, opposite over hypotenuse. Sine of C, opposite over hypotenuse. So I just rearrange it and say that h is a times c. You're taking and saying that this hypotenuse multiplied by the sine projects it and gives us the vertical projection. Remember, sine projects to the vertical component of things. And so h is a times the sine of c like this, okay? So then what we're going to do is we're going to say that the area of this triangle is 1/2 times the base times the height. And so the area is 1/2 times the base of the triangle. It's the same base times the height, but I'm using a new height calculation, this one. Base, the b should be here. 1/2 times the base times the height, a times the sine of the angle C. Let me just double check myself. 1/2 BA sine C. So now we have an area calculation for the triangle that looks a little different. Notice that this one has a sine of the angle C in it. This one has a sine of the angle A in it. Now we are able to set these areas equal because it shouldn't matter how you calculate the area of the triangle, the area is the same. So we should be able to take this thing and set it equal to this thing, but we don't want to do it just yet because there's actually a third way that we can calculate the area of the triangle, and we're going to get the same area. We're going to set all three of them equal. All right, so let's go down under here and figure that stuff out. So let's go and draw another picture because we're going to need another picture. The picture is not going to be difficult. But it is a different picture. I hope I don't mess it up because it's kind of important. So here we have the x-axis, here we have the y-axis, and I'm going to draw this triangle a little bit differently. Up like this, down like this. I mean, it's not an exact copy of it, but it's the basic idea. All right, then we have, this is angle A, this is angle B, this is angle C, and then what we have is this is side B, and this is side C, and this is side A. Now, what we did before is we wanted to find 1/2 times base times height, right? And we use this as the base, right? But actually, now in this case, we're going to turn our head sideways, and we're going to say this is the base of the triangle. This is the base of the triangle. Because remember, when you use 1/2 times the base times the height, it actually doesn't matter what side of the triangle you count as the base. If you know one side and count it as the base, as long as you know the vertical height from the base up to the tippy top, base times height, 1/2, then you get the area. So we're going to turn our head sideways and we're going to say that this is the base over here. All right, so if this side is now the base, if I just do it differently, then where will the height fall? Well, the height is going to be this one that goes down like this, and this is going to be the height right here. Remember, 1/2 base times height. That's all we have to do. But in this case, let's calculate over here. Or, yeah, let's calculate over here. Let's do number 3 area. Right? Number 3 area. So what is the height here? How do we write the height? Well, we write the height as the following. If we turn our head sideways, where is the right angle in here? The right angle is right here. Well, there's a right angle here, and there's also a right angle right here. So there's a couple of different ways to write it, but we're going to write the h right here as c times the sine of angle B. We want to write it in terms of sine B because we want to have sine B in the law of sines later, right? But make sure you understand it. If you recognize there's a right angle here, then C has to be the hypotenuse. If you're just looking at this as a right triangle, this is a right triangle now, right? This is a right triangle. If this is the right angle, this has to be the hypotenuse. And if you take this hypotenuse and multiply by you got to turn your head sideways like this, the sine of this angle, it's going to project and give you the vertical component. Or another way to think about it is the sine of this angle is this opposite side divided by its hypotenuse. The sine of this angle is its opposite side, h, divided by its hypotenuse, right here, c, because c has to be the hypotenuse. Or you can think of it as the hypotenuse c times the sine of the angle projects it and gives me the vertical component. But the problem is because the triangle's turned upside down, what's vertical looks a little different to you. So you might have to twist your head around and realize that projecting this thing, this does give the vertical component when you multiply times this sine. If you could flip this triangle over in your head, it would read a little bit easier. But this h is c times the sine of b. So then we can say that the area is 1/2 times the base times the height. But this area is 1/2 times the base of the triangle, which the base is now a over here, times its height. But the height we just wrote was c times the sine of b. C times the sine of b. So 1/2 ac times sine of b. All right, so now we have calculated the area 3 different ways, and they all should give you the same number of square millimeters or square meters or whatever, because the area of the triangle, no matter how you calculate it, it's the same. So this area, that whatever we find, has got to be equal to this area, whatever we find, has got to be equal to this one, whatever we found. So let's write this down. So this area was this, 1/2 times BC sine A. BC sine of the angle A. And that's got to equal this area, 1/2 times BA times the sine of C. But that's got to equal this area, and I'm gonna need a little more room. Sorry about that. 1/2 AC sine B. 1/2 AC C sine of B. So let me go kind of draw a little divider right here. So this area is equal to this area and is equal to this area. Notice we have a sine A, a sine C, and a sine B in there. Now what do? Well, 1/2 is common to everything, so we can divide by 1/2. What we're going to actually do is we're going to divide this entire thing by the following: 1/2 times A times B times C. And remember, any equation, you can do whatever you want to both of them, so that means I have to divide this one by 1/2 times A times B times C. And that means I also have to divide this one by 1/2 times A times B times C. So what's going to happen is the 1/2 is going to cancel, the B is going to cancel here, and the C is going to cancel. And 1/2 is going to cancel here, and B is going to cancel here, and A is going to cancel here, and 1/2 is going to cancel here, and A is going to cancel here, and C is going to cancel here. And what do we have left? The only thing left is sine of A, angle A, over lowercase a. And then we have sine of C, or let me write the B one first, sine of B over B. And we have sine of C over, only thing left is C, sine C over C. And this is the law of sine. So there are other ways to prove it, I'm sure, but this is the way that is presented to most students on how to actually prove it. And it's inequality of areas, right? We write the area of a triangle 3 different ways involving the sine of the 3 different angles. The areas should all be the same, so we set them equal. And then we just divide by a common term, and we can get this into this familiar form. You could say that what we had written here before is also the law of sines, but this is a much more useful version of it that we can use to solve problems. Now, if I asked you, just randomly, prove the law of sines, would you have come up with this? I'm not sure I would have, to be honest with you, because what you have to do is you have to think, well, I'm going to write the area 3 different ways. And I'm going to write the area in 3 different ways with 3 different versions of the height h, and then I'm going to set them equal. Mathematicians do this, and this was done a long time ago, and a lot of times they go down paths to prove things and they hit dead ends and it doesn't go anywhere. This way, when you calculate the areas and you get down to the end of the path, it gets to something very useful, this thing. But I guess what I'm trying to tell you is I'm hoping you can follow this, but I'm not expecting you to know how to do this ahead of time. You know, I'm mostly trying to allow you to understand it, so you say, okay, I can follow that. That is something I can understand. This is not magic, okay? But if I were to just tell you yesterday, prove the law of sines, I probably wouldn't have been able to do it because we all learn by example. We learn by doing. Somebody spent hours and hours, maybe days, trying to figure out this proof and to even see if it was proved to be something useful. So I hope you have enjoyed this lesson. We learned what the law of sines is, we learned how to use it, and we learned how to prove it. So now what I'd like you to do, go through this lesson again, make sure you understand everything. Follow me on to part 2. We'll continue to get more practice using the law of sines.